That's good. All right. So on the AP Classroom, so let's look through. On the test, there are 11 questions that you're going to go through. 10 of these are multiple choice. The last question that you have is a free response question. So question number 1 looks at 2 different machines that are making the same part, and we look at the number of defective parts produced by each machine during the first hour of operation on 19 randomly selected days. So there's 19 dots there. The scatter plot shows the number of defective parts produced by each machine on those days. So for instance, the dot here would show you that machine A and machine B both had 10 defective parts in that first hour on that day. Okay, so it asks which statement gives the best comparison about the number of defective parts produced by the machines. So you're just going to read through those and kind of eliminate using the scatter plot. Okay. Question number 2. An agriculturalist working with Australian pine trees wanted to investigate the relationship between age and height of the pine. A sample of pine trees was selected, and the age in years and the height in meters was recorded for each tree in the sample. Based on the data, they created the following regression equation. This is the equation. Your predicted height is equal to 0.29 plus 0.48 times your age. Which of the following is the best interpretation of the slope of the regression line? So you can look back at your notes for slope and how you interpret slope. And remember, slope is the number, obviously, that goes in front of x. And x, in this case, is your age. So you know where your slope is, and then you want the best interpretation of that slope. Number 3, you get a computer printout. Based on the computer printout, which of the following is the best interpretation of the value of the slope? So you want to look at the computer printout, and remember, it's in your notes, it's in the video, it's all over which number is the slope and the best interpretation of that. Number 4, we did get a table 1 in here. So that takes you back a chapter. First year students enrolled at a college were asked whether they played video games. The responses classified by whether the students were enrolled in the School of Science or School of Arts. Of all the students enrolled in the School of Arts, who responded? So we're only looking at arts. Approximately what proportion said they play video games? So that should be a pretty easy one for you. Number 5, which of the following scatter plots has a correlation closest to 0? And you get 5 different scatter plots to look at. Number 6, in a recent survey, high school students and their parents were asked to rate 60 recently released movies. So there's 60 dots there. The ratings were on a scale of 1 to 9, where 1 was horrible and 9 was excellent. So notice nobody went to 10. It's just 1 to 9. For each movie, the average rating of the students and the average rating by their parents was calculated, and the scatter plot below was constructed. The horizontal axis is the student rating. The vertical axis is the parent rating. So an individual point is, again, the rating of a single movie. For instance, in this movie, the student rated it a 4.5. The parent rated it a 2. It's the same movie, same one that they're rating. So you have 60 different movies there, and they are rating those, okay? The question says, which of the following statements is justified by the scatter plot? So you have to be looking at the scatter plot and make sure that that answer goes through. Again, I would read on these AP exams, I would read all of the answer choices to eliminate answers. Residual plots from 5 different least squares regression lines are shown below. Which of the plots provides the strongest evidence that its regression line is an appropriate model for the data and is consistent with the assumptions required for inference for regression? So you remember, in a residual plot, you want there to be no obvious pattern, and you want scattered data. If you have an obvious pattern in a residual plot, then you have a bad linear correlation. 8, there is a linear relationship between the number of chirps made by the cricket and the air temperature. A least squares regression line gives this model. X is the number of chirps per minute, and Y hat, our prediction, is the estimated temperature in degrees Fahrenheit. What is the estimated increase in temperature that corresponds to an increase of 5 chirps per minute? So basically, if I put a number in there for X, and then I put a number in there 5 more than that, how much did it increase by? So if you increase by 5 more chirps, how big of an increase is that? Okay, is the question. All right, so you could pick numbers if that helps you to go through that one. Which of the following scatter plots could represent a data set with a correlation of R equals -1? Remember, that would be a perfect negative correlation. 10. Data were collected on the fiber diameter and the fleece weight of wool taken from a sample of 20 sheep. The data are shown in the following graphs. Graph 1 is a scatter plot of fleece weight versus fiber diameter with the least squares regression line shown. Graph 2 is the residuals. Okay, so you get a scatter plot and you get a residual plot. It asks you, one point is circled on graph 1. There are 5 points labeled A, B, C, D, and E on graph 2. Which point on graph 2 is the residual for the circled point on graph 1? So remember, residual tells you the actual minus the predicted. And then the free response question. A student measured the heights and arm spans rounded to the nearest inch of each person in a random sample of 12 seniors at a high school. So there's 12 dots here. Scatter plot of arm span versus height is shown. Based on the scatter plot, describe the relationship between arm span and height for the sample of 12 seniors. You need to specifically describe the direction. You need to specifically describe the form and specifically describe the strength based on the scatter plot, not on anything else. Okay? Let X represent the height in inches. Let Y represent the arm span in inches. 2 scatter plots of the same data are shown below. Graph 1 shows the data with this least squares regression line, and graph 2 shows Y equals X. So Y equals X would mean their height and their arm span is the same. Okay? So the first one is a prediction line. The second one, the graph, is just saying, what if their height and arm span is exactly the same? That's the line. Okay? It says, criteria listed, or the criteria described in the table below can be used to classify people into one of 3 body shapes. So they call you a square if your arm span is equal to your height. Okay? They call you a tall rectangle if your arm span is less than your height. And they call you a short rectangle if your arm span is greater than your height. Okay? Those are just ways they classify you. For which graph, 1 or 2, is the line helpful in classifying a student's body shape as square, tall rectangle, or short rectangle? Explain. And that actually is very obvious. Okay. Now, then you want to complete the table for the 12 seniors. So how many of those 12 are squares, meaning their arm span is equal to their height? How many of those 12 are tall rectangles, meaning their arm span is less than their height? And how many of those are short rectangles, meaning their arm span is greater than their height? Then it says, using the best model for prediction, so using the prediction equation they gave you before, calculate the predicted arm span for a senior with a height of 61 inches. So you use the prediction equation given to you and show your work, how you plugged it in. Calculate the predicted arm span for a senior with a height of 61 inches. And that is the entire Chapter 3 test.